Hello students, welcome to my channel Cam Solution. Today we will discuss the most important chapter, solution, which is the important part in NEET as well as board exams. We will cover the full chapter in two parts, so we will today do the first part. And for one more information I want to give to you, uh, those who need the notes, please contact me on 9468541627. Okay, this is the WhatsApp group. I will provide the notes of board exams every chapter. Clear? So before we proceed, please like and subscribe my channel. Let's begin. Okay, so what are the solutions? Are homogeneous mixture. Homogeneous mixture, there are two types of mixture are there: homogeneous and heterogeneous. Homo means same composition throughout, and hetero means different composition. Means, for example, if we take salt in water, the salt will dissolve fully in water. We cannot differentiate it, so it is the homogeneous mixture. And on the other side, if we take oil in water, we can easily differentiate oil in water, so this is the heterogeneous mixture. I think this is clear. Homo and hetero, uniform composition you can say, and here non-uniform composition is there. So solution is a homogeneous mixture of two or more substance. Okay, so now the components we can decide. If two components are there, then it will be the binary solution. If three will be there, ternary solution will be there. Okay, solution will have two parts: solute and solvent. Solute in binary solution, solvent is a component which is present in the large quantity, more quantity, while other component is known as solute. Let's take water in a beaker. Okay, this is the water. Here we add a small amount of salt in it, that will be the solute. And after adding the salt in it, this will be the solution. Before it is the solvent. Okay, so after adding it will be the solution. Solute plus solvent is equal to solution. Clear, guys? Second, we can say the water. If water is solvent, the solution is called the aqueous solution. There are many solution we can say. If water is the solvent, then it is known as aqueous solution, and if no water is not there, we will call it non-aqueous solution. Clear? There are three types of solution: unsaturated, saturated, and supersaturated. Now take me the example of saturated solution. First of all, a solution in which no solute can be dissolved further at given temperature. At given temperature, no further solute can be added. The quantity will be full at given temperature. Okay, that solution is called saturated solution. You can see here in the diagram, no more solute dissolved. The quantity should be fixed. Example, we go on the dinner to eat the food. So in dinner we like the food and we will eat so much, and no more hunger is there, so no more food can be eaten. So that is will be the saturated solution. Clear? At given temperature. Non-saturated solution, a solution in which more solute can be dissolved without raising temperature. More solute can be dissolved. Okay, more solute, they has capacity to dissolve more solute. That is called the unsaturated solution. Third one is supersaturated solution. Amount of solute dissolved then that would be necessary to saturate it at given temperature. Solute is there already, but more solute is added, it will form a crystal like structure. Okay, a solution which contains more solute then would be necessary to saturate. It contains already a solute, again we are adding the more solute in it, that form the crystals, that will become the super saturated solution. That extra solute will be the crystal form. Okay, that become unstable and undissolved. I think this is clear. Saturated, unsaturated and supersaturated. Next we are moving towards solubility. What do you mean by the solubility? The maximum amount of solute that can be dissolved in a given amount of solvent. Let's say 100 gram of solvent. How much solute can be dissolved at a given temperature? Okay, that is the solubility. We can define that solubility is dependent on the different factors. Number one, nature of the solute. What is the nature of solute? Second one, nature of the solvent. Third one, temperature of the solution and pressure. These are the four factors it can ask in the multiple choice questions, so remember this. Next, moving towards the Henry's law. Henry's law is important as in the board exams also. Majorly Henry law tells that the solubility of the more the pressure of the gas, pressure on the gas, the more will be the solubility. The more will be the solubility of the gas. This is the Henry law. The most commonly used form Henry's law state that the partial pressure. Now what terms use partial pressure is there. It is on the pressure, more will be the vapor phase is proportional to the mole fraction. How much gas is dissolved? Okay, it is dependent on the pressure of the gas. More will be the pressure, more will be the gas will be dissolved. Okay, so the formula is equal to P is equal to K H dot X. K is the Henry constant. X is the mole fraction. Mole fraction is the concentration term we listed here. Greater the value of KH, higher the solubility. Okay, the solubility is proportional to the KH value. More will be the solubility, more will be the KH value, and it is inversely proportional to temperature. As the temperature increases, the solubility will decrease. Clear? Solubility will decrease. This is the temperature. Okay. This question may be asked in the question exam. Aquatic species are more comfortable in cold water than in warm water. You know, in warm water temperature is more, then the required oxygen level will be also be less in that. Okay, so the aquatic species need more oxygen to be comfortable in their life, their aquatic life. So they are comfortable in cold water because the temperature is low. Solubility less, more amount of oxygen is there. Okay, this will be the question. Next, applications of Henry law. As we have seen in the soft drinks or cold drinks, we have seen that more the pressure we apply, then more will be the CO2. More will be the pressure we applied, the solubility of the gas will be the more. Okay, this is the application of Henry law. And second one is the at higher altitudes, at higher range, the pressure of O2 is less. We know that as we go upwards, the O2 level is less, and the concentration, this is leads to the low concentration of O2, the condition which leads to anoxia. This is the disease which occurs in the high altitude in the deficiency of oxygen. Now the concentration terms. What is the concentration? Amount of solute present in the solution. Okay, these are the concentration. Total there are 8 concentration terms. I am only describing here the important terms only. So amount of solute present in a solvent is a concentration. First of all, on the basis of the solution, there are two types of solution we have seen here. Now the first concentration term is mole fraction. Mole fraction means ratio. Ratio of what? Ratio of number of moles of component to total number of moles of all component. Let's say the example, two components are there, A and B. Okay, so we have to find out the mole fraction. So if you have to find out the mole fraction of A component, this is the symbol of mole fraction. This is known as chi. Okay, then it will be equal to XA upon XA plus XB, chi B. Okay, this will be the mole fraction. As we have to find out the mole fraction of B, then it will be the like this, chi A plus chi B. Okay, ratio of that component to the ratio of all the component present. Okay, A and B are the components. NA and NB you can say, or XA or XB you can say. The mole fraction A will be, I have given the formula. Clear? Next, parts per million. Parts per million, where we have used parts per million in trace amount, where air pollutions and air particles are there. So number of parts of component divided by total number of parts of all component. One component, okay, divided by all component into 10 raised to power 6. This is 10 raised to power 6. Okay, so this is 10 lakh. Here the parts per million is also a concentration term. Next, we are moving towards the molarity. We have defined it from big M, number of moles of solute, divided by volume in liter. The liter volume will be of solution. It is of solution. Because here volume is there, it will depend on the temperature. Okay, the more will be the temperature, less will be the molarity. Okay, so you have to see that it is the unit will be mole upon liter. Mole upon liter will be the unit of the molarity. And in numericals, what you have to remember that WB, mass of solute, molar mass of solute, okay, into 1000 upon volume in ml. If here liter is there, then you do not have to take 1000. Okay, so this is the formula of we will use in the numericals. Okay, now the next part is molarity of solution is 1 m, it is called molar solution, and 0.1 m the solution is called decimolar, and if 0.5 m solution is there, it is known as semi-molar solution. Semi means half. This is dilution law, m1 v1 is equal to m2 v2, which is we have used in the titration practicals. Okay, where one is known and second one is unknown particle is there. Next, moving to the next concept, molality. Molality is the number of moles of solute per kilogram of solvent. Per kilogram of solvent is there. Mass upon of solute, mass will be given in kg, kilogram. Okay, so mass of solute in gram upon molar weight of solute, we can write like this, small m is equal to WB upon, this is the mass of solute, molar mass of solute, 1000 upon weight of solvent. This is the formula. This will be the formula, okay, for the numericals. It will not dependent on the temperature because it is the mass quantity. Mass will not be dependent. Solvent used is water. 1 molar solution is more concentrated than 1 molar solution. 1 m is more concentrated than 1 m. Here will be 1 small m. Clear, guys? Next and most important law is Raoult's law. Raoult's law is important, as we will discuss in the this video. We have to take the two volatile liquid. Volatile means which are vaporize easily. Okay, vaporize. Two volatile liquids will be there. So the vapor pressure of each liquid in solution is less than the respective vapor pressure of pure liquids. Means this, in simple language we can say the vapor pressure of the solution will be directly proportional to the mole fraction. It is the Raoult's law. For example, I can write the equation here. Pa is equal to Pa naught XA, okay, and Pb is equal to P naught B is equal to XB. Here this is the partial pressure of A component and this is the pure pressure of A component. Okay, this is the reaction formula of Raoult's law. Next, there are two solutions on the basis of Raoult's law. Ideal solution, which follows Raoult's law, is known ideal solution, and there is attraction between the solute and the solvent particles. Attraction between solute and solvent particles. The solution in which solute BB and solvent A interaction are almost similar to the solvent solute interaction. Means if A and BB interaction is similar to the AB interaction, this is the positive derivation and it will follow the Raoult's law. Clear? Next, moving towards the examples. Examples are same: benzene and toluene, and hexane and heptane, ethyl iodide, ethyl bromide, chlorobenzene and bromobenzene. This same meaning formula we use. It is the positive. This is the ideal solutions formula examples. Okay, so let me give you the graph of Raoult's law. Okay, here we will take the mole fraction, and here we will take the vapor pressure. Here Xa is equal to 1, Xb is equal to 0. Here Xb is equal to 1 and Xa is equal to 0. Okay. Now mole fraction will be in this direction, and this will be the Pa naught. Okay, so as the mole fraction decreases, vapor pressure will also decrease. Vapor pressure of Pa, suppose this is the vapor pressure of Pa, it will also decrease, and this will as the vapor pressure of A component will decrease, the vapor pressure of B component will increase. So this is of Pa and this is of PB. And what will be the total? Total will be like this: P total is equal to Pa plus Pb. This will be the graph of Raoult's law. Now there are different solution, non-ideal solution are also there, which do not obey Raoult's law. There are two types of solution: positive deviations are there and negative deviations are there, which shows non-ideal solution. In positive deviation, the interaction, the AB interaction are weaker than AA or BB interaction. Okay, weaker. AB interaction are weaker than A and BB. Clear? So in this case, change in heat and change in volume will be equal to 0. Okay, will be equal to 0. Now in non-ideal solution, negative deviation, A and BB interaction are observed in vapor pressure of each component. Total vapor pressure are lesser than the predicted Raoult's law. AB interaction are stronger than AA and BB. This is the non-ideal solution showing negative deviation. Clear, guys? So on the basis of negative deviation, we can say that here delta H is not equal to 0 and delta V will change in volume will also not equal to 0. One is endothermic process and one is exothermic process. Okay, azeotropic mixture, it is the mixture of non-ideal solution. Azeotropic mixture also known as constant boiling mixture. Which have same composition in vapor and as well as liquid phase. Composition in vapor and liquid phase. Okay, they are formed by non-ideal solutions. There are two azeotropes, minimum boiling azeotrope and maximum boiling azeotropes. You have to remember the examples of both the azeotropes. Which show positive deviation is the minimum boiling azeotrope and which shows negative deviation is the maximum boiling azeotrope. Example is ethanol plus H2O is the example of minimum boiling azeotrope, and H2O plus HCl is biomass will be example of maximum boiling azeotrope. Now this is all about the first part of solution. I hope you understand the video, and I will definitely come soon to you for the next part of the solution. I hope you like the video. Please like and subscribe my channel. Thank you. Have a nice day.